Right. We will see theory of computation, its weightage in the GATE examination. Theory of computation. In short, we call it as TOC. The subject mainly contains the introduction part, the introduction, right? And what about the definitions of NFA and DFA, their difference, and also the regular expressions and conversion of regular expressions to finite automata and finite automata to regular expressions. Also we have, if you are given finite automata, how to convert it to regular expressions also we can have questions on this. And context free languages, context free grammars, context free languages, and push down automata. Push down automata. Okay, separately to for every context free grammar we can design a, again in the push down automata, DPDA and NPDA. And the last concept is we are having Turing machines. From the last few years, if we observe the GATE question papers, so we are getting minimum 3 marks we are getting, maximum 8 marks we are getting from the subject theory of computation. And in the average case, we are getting 6 marks, almost all the topics. Again, individual, we don't have any separation in this. Almost definitely one question from PDA will be there. So for 2 marks, max or min, from CFLs and push down automata we have. Then definitely one question we have from NFA, DFA and all these things. Minimum 1 or 2 here. So here we are getting minimum 1 or 2, and the remaining so 2 to, so here it is 2 to 4 marks we are getting from PDA. Suppose if it is 4, if it is 2, and Turing machines, in this again we are having what type of languages, recursively enumerable, Chomsky hierarchy, type 0, type 1, type 2, type 3, etc. recursively enumerable languages and all these things. So in this only we are getting, so P and NP definitions, at least what type of problems are of what type, definitions and all this, maximum 2 marks we are getting. So this is the split, maximum 8 marks there is a possibility, and in comparative design also we have maximum 6 to 7 marks, maximum it is, sorry, okay, that is maximum 8 marks we have, maximum marks. Right, total TOC and comparative include 15 marks around they will coverage out of your total number of marks for the GATE computer science paper. Almost the same case for the IT. For IT case we are having somewhat lesser compared to this, and we will discuss each and every topic in detail, and on every topic I have given the previous, I am giving the previous GATE solved questions and solutions along with explanation, and at the end of the subject I am giving the overall all exercises and previous GATE papers and their solutions and analysis also. In each and every topic I will explain the definition and also some example problems, some previous GATE problems also I will explain. So you can contact me at any time, this query, the same WhatsApp and same number, the email ID also will be active 24/7, and that's what. And now we can start with the introduction of the subject for the GATE CS and IT also this includes, okay, and that is the introduction part. Right, we will discuss about automata theory, theory of automata or automata theory. Automata theory. My name is Professor Veerabhadram of CSE Department, Computer Science Engineering, having 20 years of experience in the teaching of regular BTech, MTech and the GATE students also. Automata theory. So we can also call this as theory of automata. And what do you mean by automaton and automata? Briefly speaking, automaton is a machine. So normally we have to call it as automaton is a machine. It's a finite machine. Automaton is a finite machine, as all we have studied in your BTech level. It's a finite machine which has certain input and certain output. And to define this, for which purpose the automaton will be useful, this finite machine will be useful, what kind of languages, and what kind of inputs the machine will accept, and what kind of output it will generate, and how many types of this automaton, this finite automata, also considered as finite machine, and all these things we will discuss in this subject. So before defining the finite machine, we have to define certain symbols or certain terminology related to finite automata is very important. So the basic terminology in the theory of automata is, the first one is, what is a symbol? What do you mean by a symbol? A symbol is a single literal. A symbol can be considered as a single entity or single object. We can consider it as a single literal or entity or object related to the strings accepted by a finite machine, a single literal or a single entity. So a symbol can be, for example, a symbol can be a 0 or a 1 or a or alphabet like this, or 0 or 1 or x or y, or anything can be symbol, or a null, anything can be considered as a symbol, a single symbol. Such kind of group of symbols we can consider it as, the group of symbols considered as a string. A string is a group of symbols, of input symbols or simply symbols. A group of symbols can be considered as a string. So as I have already told, these symbols are like this. So group of symbols means like 0 0, so 0 1 1, any number of what we call as symbols combination, 2 2 3 3, single combination, or anything can be considered as a string like this. Any number of zeros or ones or b's or whatever it is, anything can be considered as a string of symbols, right? What are the acceptable symbols and which are not acceptable in the finite automata or finite machine should be clearly defined before defining a finite machine. A string, what kind of symbols the automata or the finite machine will accept should be defined very clearly. A symbol and a string. And one more thing is, what is an alphabet? What do you mean by an alphabet? Just observe. So an alphabet is a group of symbols, right, or group of what we call as group of symbols, right? Okay, alphabet. Suppose if you consider English alphabet, the English alphabet consists of the letters from A to Z, that is English alphabet. Telugu alphabet, A to Bandira is Telugu Varnamala, Hindi Varnamala. Alphabet is set of all possible characters for any specific language, that is a programming language, or that is any general communication language. For English, if you consider, for English is a communication language, the alphabet allowed for English is A to Z. The alphabet allowed for Telugu is A to Bandira. And we have certain Varnamala which is acceptable for the communication language like Hindi. They are all communication languages. So now here language we are discussing about formal language. So here we consider them as formal languages. So formal languages are different from our communication languages. The languages which are completely formal with respect to a computer or a machine. An alphabet is set of all acceptable symbols. Set of what we call as input symbols for a finite machines can be considered as an alphabet for that machine. An alphabet for that machine. Suppose for a machine, if you say, normally we denote with sigma. An alphabet, if you say 0, 1, the machine should accept only the strings containing only zeros and ones. Suppose if the alphabet is given as A, B, the machine should accept the strings containing only A and B. Or X or Y. Suppose alphabet is given as X or Y, right? So it should accept only the strings containing X or Y and so on, etc. Normally we take in the alphabet generally 2 symbols for a finite machine. There is no rule that to take only 2 symbols. The A machine can be accepting any number of symbols also, A, B, C, and etc. Right. Once we define this fundamental terminology, every finite machine, right, we get these terms, symbol, string, alphabet everywhere and throughout till the end of the subject. That's why these terms should be remembered very clearly. An alphabet. So what is an alphabet? What is a symbol? And what is a string? And next one to define on this fundamental terminology is what we call as a closure, or what do you mean by a clean closure, and what do you mean by closure of a given symbol. What do you mean by clean closure? So normally we represent a clean closure with a symbol called a star as a superscript over any symbol. Suppose if I am given, so what is a clean closure? 0 star if I say. So what do you mean by clean closure is 0 or what do you mean? This is 0 or more number of occurrences of a symbol. 0 or more number of occurrences of any symbol on which this star is mentioned. On which this star is mentioned. Of a symbol or a unit, what it can be. Sometimes the star can be covering a group of symbols, that is called as unit. Right. 0 star if you say 0 or more 0 occurrence of the 0 means empty null string. More occurrence అంటే 1 occurrence, 2 occurrences, 3 occurrences, 4 occurrences and infinite number of occurrences. All the set of strings will be considered as a set, and this set can be represented by a single notation like this 0 star. Whereas this kind of representation is not available for our normal set theory in algebraic sets. So that's why here this set is called as a regular set. So this kind of sets are called as regular sets whose members are normally not countable, means infinite. This is an example of regular set. Normally the elements or members in regular sets are not finite, indicating not finite number of elements. Whereas our algebraic sets number of A is equal to 4 or 5 or 100 or 1000 etc. The elements in our regular the elements in our normal algebraic sets are finite, countable, whereas the number of elements in the regular sets are infinite. Here if you observe, the number of elements here are infinite. We don't have certain count. Therefore we cannot have formulas like number of A is equal to number of A and B is equal to number of A plus number of B minus number of A and B. Like that formula we don't have for regular sets. The number of elements in the regular set is not finite, it's simply infinite. Suppose if star is covering say some single symbol 1, so then we can take it as the epsilon 1. So 2 occurrences, that is 2 occurrences, 3 occurrences, 4 occurrences and so on up to infinity. It is also 1 star. Suppose if you say, so this star is covering say simple like this 0 1 whole star, then the star is covering not single 0 or single 1, this entire unit. Therefore if you consider this entire unit, you have to consider at a time. You should not split this 0 and 1 because the star is covering this. Therefore 0 occurrence of this unit, 1 occurrence of this unit, so 2 occurrences of this unit, then 3 occurrences of the same unit and 4 or 5 or infinite number of occurrences of the same unit. Right. Similarly, it may be defined as 1 1 star. Right. Like this also we can say 0 occurrence of this unit, so 1 occurrence of the unit, so 2 occurrence of the units. So we cannot have 3 ones in this regular set. We cannot have 3 ones is a member of this set because 1 occurrence, 2 occurrence of the entire set, because the star is covering this entire unit. We have 3 occurrences, 4 occurrences or 5 occurrences, 1000 or 1 lakh occurrences of the entire unit, not single. Therefore, there is no question of 3 ones arising in this, what we call as in this regular set as a member of this regular expression. This kind of expressions containing a closure or what we call as clean closure can be considered as regular expressions because they are not normal algebraic expressions. That also we will discuss later. So for time being, 3 ones cannot be there because 2 occurrences or 3 occurrences like this means 3 occurrences means 6 ones will be there, right? 4 occurrences means 8 ones will be there, 8 right, like this, and infinite number of occurrences. Therefore the set of ones containing only even number of ones, this will indicate. Not only like this, sometimes the units may contain combination of zeros and ones also. Suppose if you are given, so 0 followed by 0 1 whole star, if I say 0 followed by 0 1 whole star, so what this indicates is first one must be a 0. So first one must be a 0. So this unit can be 0 or more number of occurrences. According to this, suppose if this is empty, 0 followed by null string is simply 0. The 0 is mandatory because we don't have any star or plus on this. This is mandatory in every string. So according to this, if you observe 0 or 0 1 whole star, 0 occurrence of this unit, 1 occurrence of this unit, that is 0 followed by 0 1, and 2 occurrence of this unit, therefore 0 followed by 0 1 This 0 is mandatory for everything, because here it is given like this, right? Then 3 occurrences of this unit which is covered by whole star or simply star. So like this kind of strings. So in this there is no possibility of some kind of strings like 0 1 1 0. So there is no possibility of two consecutive ones in this regular set. In this regular set, for every regular set we can have an equivalent regular expression. As these are sets, the corresponding these expressions, these are called expressions, and the expressions are called as regular expressions, and the corresponding sets are called regular sets. Every regular set has certain equivalent regular expression, and every regular expression has an equivalent regular set. That is what your regular expression, difference between normal expression and regular expression. So like this, suppose if you consider the strings sample here, there is no possibility of the string which contain two consecutive ones definitely. Like this we can write. Okay. So therefore, infinite number of occurrences of the unit and followed by 0 is mandatory. So like this we can have. Okay. Then also, suppose you are given sometimes 1 followed by 0 star followed by 1 if we are given like this. So what it is indicating is very clear. The first one is mandatory, the ending one is mandatory. So in between you can have any number of occurrences of this 0. Therefore 0 occurrence of this 0, that is indicating 1 1, that means epsilon. If you don't write epsilon middle or somewhere here or here anywhere, any number of epsilons are assumed to be available, because epsilon indicates null string only. 0 occurrence of this unit, then 1 occurrence of this unit will give 1 0 1. Then 2 occurrences of this unit will give 1 0 0 1. Then 3 occurrences will give 1 0 0 1. Then 4 occurrences of the covered part by the star will be 4 occurrences, 3 occurrences, 2 occurrences, 1 occurrence and 0 occurrence. So this starting one, ending one is mandatory. Therefore you observe the nature of strings, what kind of strings you are getting here. Okay, all the strings simply here if you observe starting and ending with 1, but in the middle they contain only zeros. In the middle there is no possibility of ones only, except starting and ending with 1 containing only zeros in the middle. That kind of expressions are like that. Sometimes, okay, that is what your clean closure. And we also have another term called as closure. Another term called as closure, that is normally indicated by a plus. Normally indicated by a plus. So a closure normally defined as one or more number of occurrences. One or more number of occurrences of a symbol or a unit. Occurrences of a symbol or a unit which is covered by plus. Disclosure. In the same way you can write here the minimum number of items are 0. Here the minimum number of items are 1. That is only the difference. Suppose if I say in the same way, if I say 1 plus means, so it should be written as superscript only. You have to take care. You should not write the plus, whatever the R star, what we call as adjacent to any unit or any symbol, should be written as superscript. That is mandatory. So minimum 1 number of occurrences, suppose 2 number of occurrences, 3 number of everything is there, like star, but 0 number of occurrences is not. Minimum number of occurrences of your unit is not possible. Therefore, if you consider the difference between 1 star and 1 plus, only one difference we are observing. Here 0 occurrences of this is possible, which is not possible in 1 plus. Therefore, we can write easily your 1 star is equal to, what is the difference you are getting? 1 plus this union epsilon, because epsilon is extra item that is found in 1 star. Not only like this, you can take any regular expression. You take some R is a regular expression, R star is equivalently, so R plus union epsilon, we can generalize like this. So relationship between the star and plus. Now the converse also if you read, because this is a set containing single element epsilon. Conversely, you can express R plus is equal to R star minus epsilon. That is also equivalent only. R plus is equal to your R star minus epsilon, because union, so get this side set difference. The opposite of union is set difference only. Very simple it is, we can express. Right. Sometimes the strings are not finite length, or sorry, the strings are not this much short length. The length of the strings given can be increasing more and more also. number of different types of grid questions will be there on this, what we basing on the regular expressions only. It's very clear that these are all regular expressions, the equivalent regular sets. For every regular expression we have equivalent regular set. For every regular set we have equivalent regular expression, right? Okay, suppose you are given, consider the following regular expression, 0 or 1. Okay, before this just wait, 0 or 1, that's just set operations, just wait. Okay, right, r star. So and here okay, suppose if I say any number of strings, we can write here examples. Here it is. Okay, the possible operations. Suppose if I write some 0, here it is, this is called as or 1 whole star. If I say what is this, so there is a lot of difference between 0 1. This is concatenation. So 0 is concatenated with 1. So here is not concatenation. 0 or, this is considered as union, taken as either 0 or not plus. It is not arithmetic plus. You must consider it as, you must read it as or. So 0 or 1 whole star, or. So or means, what does it implies is, the meaning is same, 0 or more number of occurrences of this entire unit. So in that unit, the first is okay epsilon, the entire thing can be epsilon. The second string that is possible is, again you take the strings of length 1, length 2, length 3, length 4 and so on. Length 1 and so on. This is the 0 length string. Consider the strings of length 1 from this, because this is covered by the star. Length 1 strings means that one symbol in that string can be either 0 or 1. That is the meaning. Can be either 0 or 1. That is the strings of length 1. Similarly, strings of length 2 you take. The first symbol can be 0 or 1. The second symbol can be 0 or 1. That is the meaning. Therefore, first symbol can be 0 or 1. The second symbol also can be 0 or 1. These are the strings of length 2 in this 0 or 1 whole star. The first symbol can be 0 or 1. The second symbol can also be 0 or 1. Therefore, 0 0, 0 1, 1 0, 1 1. Anything can be possible. Likewise, similarly, the strings of length 3. The first symbol can be 0 or 1. The second symbol can be 0 or 1. You can write. The third place also you can write 0 or 1. That likewise you can write. That is 0 or 1 whole star. Strings of length 2. Then strings of length 3. So strings of length 2 length. Strings of length 1. Length 0 means it is epsilon. The strings of length 3. The first symbol can be 0 or 1. The second symbol can be 0 or 1. The third symbol can be 0 or 1. The first symbol can be 0 or 1. The second symbol can be 0 or 1. The third symbol can be 0 or 1. You can write whatever you want, you can write. So like this, if you observe, you can get 0 0 1. All three combinations like binary strings we have. You have two locations, first place, second place, and you have three locations and you have possibilities are 0 or 1. Therefore, you will get total number of possibilities according to permutations and combinations. Or in general digital logic and logic design, you can get number of places are 3. Every place we can fill with 2 options, either 0 or 1. Therefore, 2 into 2 into 2, that is 8, 2 power 3. Suppose your number of locations are 4 and every place can be filled with 2 items. First place can be filled with any one of the 2, therefore 2. The second option for this, what we call a second place, is also number of possibilities. The third place number of possibilities, the fourth place and fifth place and so on. How many places you have, accordingly you will have binary strings. Therefore, you can simply write the binary strings of length 3. Obviously, you will get 8 0 1 0, right? And 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Therefore, 5 plus 3 total number of 8 and like this and so on up to infinity. These are all length 3, length 4, length 5, length 100, length 1 lakh, length 1 crore. This is the most popular and very important string, very important regular expression you must remember, because this kind of expression each and everywhere we will get till the end of this subject, entire automata theory, not only automata, compiler design also. till the end of this gate section, Automata and compilers, 0 or 1 whole star is the most important reply expression. Most frequent, we can say. Instead of important, we can say the most frequent. Each and everywhere, every page you can find this kind of 0 or 1 whole star. Not only 0 or 1, you can write A or B whole star also in place of the symbol. What the symbol you write, simply you can write according to that symbols, you can just replace the symbol. That's very important. So, if, according to this, suppose if I write 0 followed by 0 or 1 whole star. So, what they represent? And the 0 is mandatory. So, in this part we can have epsilon because it is 0 or more number of occurrences of this entire unit. Single 0 you will get. Then, if you observe here, so first is 0 is mandatory. Of string, first 0 is mandatory. In this we can have symbols of length 1 like this, length 2 like this, length 3, all are common, just augmenting a 0 for this regular set, just augmenting a 0 before that, just to start off every string means 0 epsilon is 0, 0 followed by 0 is 0 0, 0 followed by 1 is 0 1, 0 followed by this is 0 0 0, 0 followed by this is 0 0 1, 0 followed by 1 0 is 0 1 0, so 0 1 1. Therefore, if you observe in all the things, first 0 is mandatory. So, totally the length, the string length as the result is becoming 2, that is different. Okay, but how to write the strings I am telling. So, the first 0 is mandatory, 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 and the remaining part strings of length 2 in this part. So, overall the string is becoming the length 3 or 4, that is okay, that anyway we can concatenate. So, because here we have the symbol called as concatenation, 0 followed by means there is no other symbol in between this, simply concatenate. The symbol is considered as concatenation. If you are writing plus, it is taken as union. Simply you are writing what we call as either 0 here or 1 or something like this. That is implied that is concatenation. Simply embedding. That is what the symbol. Okay. So, suppose if you observe this in this set, in this regular set also, if you see the strings, all possible combinations of zeros and ones you are getting here. Therefore, we can consider this expression as all combinations of or all strings of symbols, what we call as all strings of zeros and ones, every will be there, including epsilon. All strings of zeros and ones or all strings of a's and b's, if you write a plus b whole star. Therefore, this also if you observe, single 0 is there, 0 0 is there, 0 1 is there, 1 0. So, what about 1 0 in this? Is there any possibility that getting 1 0? No, because starting must be 0. Therefore, this kind of strings are not all strings of zeros and ones, because of you are adding a single 0 in the beginning. All the strings beginning with 0 we can consider it is this kind of strings. All the strings can consider it is in English. If you describe all the strings beginning with 0, all the strings beginning with 0 and all possibilities of zeros and ones, whereas 0 or 1 whole star is considered as all strings of zeros and ones. If you see the set, you can find each and every string of, you can find any string which can be made or which can be prepared by using single 1 and single 0. In this you can find any string which can be formed by using 0 and 1. Therefore, this set is called as all strings of zeros and ones, a famous and very popular expression is very popular expression it is. So, likewise if you observe, suppose if I write 0 or 1 whole star, so here it is a 0, so here it is a 0, then what you are getting here, at 0 or 1 whole star, what you are getting here. So, first 0 is mandatory, last 0 is mandatory, in between this entire unit can be epsilon, therefore it will be equivalent to 0 0. The first 0 mandatory, the last 0 mandatory. In this we can have strings of length 1, same thing, strings of length 1, strings of length 2, length 3, length and so on. Therefore, all these strings you can substitute here. Just for all of them, you add a beginning 0 and ending 0. You can easily get, for beginning 0, ending 0, you will get beginning 0, ending 0, you will get 3 zeros. Right? For this also beginning 0, ending 0 will get like this. You will get again infinite number of strings, but all the strings starting with 0, starting and ending with 0. If you observe, just what are all possible strings which are shown here, just substitute here. All of them augment or simply concatenate with a starting 0 and ending 0. So these are the strings. In English also, sometimes the gate questions will be given. So likewise, if we observe, okay, you can write any number of possible expressions like this. They are all called as regular expressions. They are all examples of regular expressions. Therefore, regular expressions will contain closure and clean closure symbols like this, and the members of for every regular expression has an equivalent regular set. Every regular expression has an equivalent set called as every regular expression has an equivalent set called as regular set. Equivalent set called as a regular set. And regular expressions will contain closure and clean closure symbols. Earlier we have discussed regular sets and regular expressions. Some of the possible types of gate questions will be like this. Which one of the following regular expressions set of strings not containing 100 as substring? Not containing 100 as substring. Okay. Observe here A, B, C, D. We have options. The first question answer. So 0 star followed by 1 or 0 whole star. Now only I have explained to you which one of the following relations set of strings not containing 100 should not be a substring. Here if you observe, in this 0 star you can have epsilon or single 0 or any number of zeros. In this 1 or 0 star whole star you can have any number of zeros and ones. Therefore, in this you can have definitely 100. Definitely you can have 100 if you observe the possible strings. If you write simply you can write here it is epsilon, here it can be epsilon, that can be epsilon. So here it can be taking single 0, or you can take single 0, 1, 1 0, 1 1, or you can take only 0 here of length 1, or any length you can take, or 0 1 0 0 1, any number of things. Therefore, you can take in this one, you can have any number of zeros in 4th, etc. etc. So if we observe, in this we can have definitely 100. We can have any number of ones and 0. First symbol can be 1 or 0. The second symbol can be 1 or 0, 1 or 0, 1 or 0. You can write 1 0 0. In this any number of 0. Therefore, so only substring. So infinite length of strings you will get. In that definitely you will get 100 substring definitely in this. Option A. So observe this 100. Suppose if you observe here B option 0 star 101 0 star. Directly you can get here. First you can have any number of zeros here followed by 101. But here you can have any number of zeros, say 1 0, 2 zeros, 3 zeros. So one possible string in this is 0 1 0 1. Any number of zeros here. Say I can write 2 zeros also. I can write 3 zeros also. And so on. Therefore, any number of strings you will get. For all the strings you are having 100 as substring. Observe C bit also. C option 0 star 1 star followed by 0 followed by 1 star. 100. Right, if we observe 100 as should not contain 100 as substring. Okay. So any number of ones here, any number of zeros here. Therefore, epsilon also you can have possible. A single 0 is possible. So 100. Right. So likewise, if you observe, yes, in this also you cannot have. So in this also you cannot have 100. Why? Because here only ones, here only zeros. Zeros only should be followed by ones. Number of ones only 0. But after 0 followed by only ones you should contain. Here if you observe, the number of options are C and D also if you observe. In this we will not get 100 at all. If you observe, any number of zeros followed by any number of ones followed by single 0 and followed by any number of ones or no ones. But here nowhere we don't have what we call as 100 cannot be a member. right? This is one option, and actually it is a given gate question earlier, therefore option C or option D. Just D if we observe 1 0 0. So the first can be any number of zeros or 0 zeros also. In the following strings, this is a single unit, this is a single unit. The first symbol can be 1 0, the second symbol can be 1 0, the third symbol can be 1 0 or 1. The fourth symbol can be 1 0 or 1. Like this. This is this one or this one, right? Likewise. Therefore 1 0 1 0 you will get, or 1 0 followed by 1 you will get, 1 0 followed by 1 followed by 1 0 followed by 1 followed by 1 0 or 1 0 same 1 0 and so on. Just you can write either first unit, that means if you have a group of symbols you can call it as unit. The first unit in first place, or in first place you can write 1. In second place also 1 0 or 1. In third place also 1 0 or 1. In fourth place also 1 0 or 1. Likewise you can go on, and the beginning should be any number of zeros, but nowhere if you observe 1 0 0. So 1 followed by 0, after that you can have only 1, the option is, or first you can have 1 followed by 1 0. It is only the option. Therefore, if you observe in this kind of strings also, there is no possibility of occurrence of 1 0 0. Therefore, for this question, it is wrongly given C and D, but marks will be given if you answer either C or D. Likewise, you have to answer. Generally, this kind of ambiguous questions will not be there, but have been asked earlier in the GATE examination. The string 110 does not belongs to this set. Okay, does not belongs to set. Suppose 110, 1 1, second option. Suppose if you observe second question, 1 1 0 star followed by 0 1 is equal to 0 1 is equal to. So 1 1 is mandatory. So this can be either single 0. Okay. Next you can have the last symbol, you can have 0 or 1. Suppose it is epsilon, last symbol can be 0. If epsilon, last symbol can be 1. Does not belongs to set. So 1 1, right, if you observe, the string does not belongs to the set. Okay. 1 1, single 0 you can have. The last you can have either 0 or 1. The last symbol you can have either 0 or 1. Right. So 1 1, 2 zeros or 3 zeros, any number of zeros or single 0, last can be a 0. Like this you can have. In this you can have. Therefore 1 1 0 1, 1 1 0 1 belongs to here. 1 1 0 1 belongs to here. Then 1 followed by 0 or 1 whole star 1 0 1. 1 0 1. If you observe this, the first symbol can be 1. The second symbol can be either 1 or 0 or 1 or 0, any number of things. In this only you can 0 or 1 whole star only you can have any number of zeros and ones. Or if this is epsilon 1 1 0 1, if it is epsilon 1 followed by 1 1 0 1, therefore it is 1 1 0 1 is a member of this. And if you observe this, so see bit 1 0 whole star you can have 0 1 whole star followed by 0 0 1 1 whole star, that is equals, if it is epsilon epsilon epsilon, everything is epsilon, right? You should have entire unit because star is there, entire unit, that is 1 0, again 1 0 or any number of 1 zeros followed by any number of 0 1s you want, you can take, and followed by this can be epsilon also, right? If you observe here, at 1 0 1 0 1 0 1 0 0 1 or 1 0 1 0 1 0, you can write 1 0 1 0 1 0, and again you can write any number of 0 1s 0 1, any number of what we call as 0 1s 0 1s 0 1s or 1 0. So 1 0 followed by 0 1, right? That is 1 0 1 0 1 0 0 1 0 1 0 1 1 0 0 1. So if you observe here, so 1 1 0 0. So nowhere you are getting the combination. If you write 1 0 repeatedly, if you write 0 1 repeatedly, or 1 0 followed by 0 1 repeatedly also, first combination you are not at all getting right. Even after this also, if you write, even after this also, if you want to write some string or some symbols, you have to write either 1 1 or 0 0. Suppose if you write 1 1, again if you write 1 1 or 0 1, sorry, not 0 1, 0 0. If you write 1 1 also, you have to write either 0 0 or 1 1 or 0 0 or again 0 0. If you write this also, you are getting 1 1 0 0. So nowhere you are getting 1 0 0 1, 1 1 0 0, 1 1 0, but not 1 1 0 1. But not 1 1 0 1. Therefore, the option should be 1 1 0 1. Should be C. If we can exercise the entire 1 1 0 1 1 what we call as 1 1 star, like this. In this you can also get 1 1 0 followed by again 1 1, like that. You can get 1 1 0 1 here. You can exercise like this. So in this way, so you can have strings, you can have regular expression and the answer. Okay, right? So many questions in the regulations, 3 or 4 questions will be given. Right, we will solve some more problems after discussion of the finite automata. Right now, I will define formally what is finite automata. So, what is finite automata? So, as I am telling, it is finite. Automata is finite. So, finite automata is a finite machine. Finite automata is a finite machine. So, containing of 5 tuple, that is initial states, some set of states, input alphabet, transition function, and set of final states. So, where Q0 is considered as initial state, Q0 is considered as initial states, and Q will be taken as set of states, and sigma is taken as input alphabet. Sigma is the input alphabet, and delta is taken as transition function. And F will be considered as set of final states. The number of final states are multiple, sometimes depending on the given question. Set of final states. Okay. Now, so with this definition, simple automata, how it looks like. All the finite automata will start. It is a 5 tuple, will start in a certain state called as initial states. For example, if I ask to design or draw a finite automata to accept the strings, suppose your question is design. See, if automata of 2 types, DF and NFA, I know very well. We will discuss the difference also. Design a DFA to accept, D stands for deterministic finite automata, to accept even number of, to accept strings, have even number of zeros over the alphabet 0, 1. The set of strings should contain only 0, 1, but the number of zeros in the strings should be even, means divisible by 2. Such kind of strings only should be accepted by this DFA, deterministic finite automata. Deterministic finite automata will have what we call as the next move from any current state is maximum 1. That also I will explain what is non-deterministic finite automata also. Deterministic, right? Suppose if I take an initial state, right, the symbol for initial state is like this. If it's a single 0, then it can move to a single state like this. So if it is a single 1, let it be in the same state. Okay. So in every state, it is having the possibility of seeing either 0 or 1. That's it. For every state, we have to define on every symbol in DFA. On any state, on any one input symbol, if a state is not defined, that cannot be considered as a DFA. That will be considered as NFA, means non-deterministic finite automata. D stands for deterministic finite automata. Right, on 0 is 1. Suppose in this second state, if it see one more 0, say let us again come to the same state Q0 for example. What will happen? Let us exercise, and if not, we can modify the diagram. Then in this state, if it's CA1, so let it be in the same state. Say for example, I am marking this as the same state as the final state as the initial state. For this problem, initial state and final state may be same, but depending on the problem to problem, the number of what is the initial state and final states may be different. Okay, now if you observe, what are the possible strings in the given question is the number of zeros should be even, means 0 zeros also is possible. Single one is accepted, means 0 zeros, or 2 ones or 3 ones, any number of zeros is accepted. And if you consider the strings containing like this 2 zeros, until like this 0 1 0, 2 zeros, here it is 2 zeros. There should not be any consecutive zeros. Need not be, not should not be. There need not be any consecutive, only even number, that's it. Count if you observe, or single 2 zeros, or any kind of strings like this if you observe. Suppose if I take a string 0 0, so Q0 on 0 is Q1 and Q1 on 0 is again Q0. Therefore, the string 0 0 started in the initial state, reached the final state. Therefore, 0 0 is accepted. 0 0 is accepted. Similarly, if we observe 1 1, single you take 1 1, right? 1 1 means no zeros, means 0 0. 0 zeros means even only. 0 is also even number only. Therefore, if you take Q0 on 1 is Q0 and again on 1 is Q0, it is also final state. Therefore, 1 1 is accepted. 1 1 is accepted. So, similarly, if you consider any string which is having even number of zeros like this, 4 zeros, right? So, if you observe here Q0 on 1 is Q0, on 0 is Q1, on 1 is Q1 only, on 0 is Q0, right? Again on 0 is Q1 on 0 is Q0, that is this 0, right? If you observe this, so this 1, this 0, this 1, so Q0 on 1, Q0 on 1 is Q0, Q0 on 0 is Q1, so Q1 on 1, Q1 on 1 is Q1 only, Q1 on 0 is Q0, this 0 is over, and this 0, Q0 on 0 is Q1 and Q1 on 0 is Q0. That is the final state we have taken, that is the final state. Therefore, the string is accepted. Therefore, we have started in the initial state and reached the final state. Therefore, this string is accepted, 1 0 1 0 0. Therefore, total number of zeros in this string are 4. Total number of zeros in this string are 4. That means divisible by 2. Even number of zeros means number of zeros are divisible by 2 only. Like this, you take any string. You can design a deterministic finite automata like this. In the examination, how the questions will be? You will be given a finite automata. What kind of language is accepted by this finite automata? Diagram will be given. So, option A, B, C, D. So, we should have write in English or in the regular expression form, so that we will see some problems.